Namaste everyone. Welcome to We Learning. And I guess you know my name, right? I'm Lavanya Elangovan, your science educator. How are you all? Fine? Good? Great? Very good. Fine. So let's start our session. And by this time, I guess you know what We Learning is, right? We Learning is an online education platform. Here we give quality education for all students like you. Here at Vista's Learning, we help students like you to stay on schedule, value their time, and also excel in your academics. So, do subscribe to our channel. And if you have already subscribed, just share it with your friends, family members, and relatives because someone out there will have the access to quality education. Excuse me. So, having said that, let's start today's session. Okay? So now tell me, is my voice clear? Was it audible? No glitches in my video also, right? If everything is fine, then we'll just start without any delay. Give me one thumbs up. Let me see. Good. Fine. So then we'll just start the session. So what are we actually discussing about? Can you guess? You have to guess actually. So what are we discussing? So we are discussing about your chapter, Structure of an Atom. So here where we'll be studying all about the atom, like what is an atom really made up of? Because you know what an atom is. All matter, irrespective of their physical state, everything is made up of atom. Right? So those small single atoms combine together to form elements. Atoms again combine together to form molecules. They combine again to form compounds. And with which all the matter that is around us is present. So atom basically is not only just in objects and things, it is also present inside you and me that you know very well. So even a single cell, or even if you take this very small mitochondria or ribosome, even that is all made up of atoms. Yes or no? Clear? So that particular atom, when we are talking, so far we have recognized 118 elements. So those 118 elements have different atomic structure. So something in them is actually different. Okay. So for that, we have to understand what is a subatomic particle of an atom. Or to be very precise, let me say what is an atom made up of? Clear? Fine. So that is what we are actually figuring out in this chapter. Correct? Good. So in our previous sessions, we were discussing about Rutherford's model, the cathode ray experiment. Clear? And then we also were discussing about another experiment and did by another scientist, right? Niels Bohr we studied, John Dalton we studied, right? J.J. Thomson we studied, the plum pudding model. Can you recall those? So if you can recall, it is really well and good. Or if you find we have to revise those, you'll have the link in the description below where you can go click on the link and you can start looking or revising those chapters. Or if you feel great, no, fine, I'm all done. Let me just proceed from this place, then we can proceed, okay? So today, neutrons, correct? See, the electron concept, you know very well, it was framed by J.J. Thomson, correct? So what did he say according to him? Where's my pen? Let me bring it 1 second. Okay, yeah, so here am I. Let me just pick my pen, okay? So according to J.J. Thomson, we had it like this, right? We'll say this to be a plum pudding model where all the negative charges are actually embedded in it. So that is what was inferred by J.J. Thomson, yes or no? So according to him, it was just a sphere, or we can say positive sphere, in which the electrons or the negative charges are just embedded in it. That's all he said. And then another scientist who came, he said no, it is not like that. It is exact the opposite way, where the positive charge is present in the center and all the negative charges are revolving around it. But he did not specify whether it is revolving in a circular. He just said it is revolving in a circular orbit, that's all. Right? He did not say how is it exactly happening? Because if any object is revolving or rotating or just moving in a circular path, will have an acceleration. So due to that particular acceleration, lots of energy will be spent out. Correct? So once for all the energy is worn out, the electron will fall back into the nucleus or into the positive sphere there, and the entire atom will collapse. So this is what these were the actual drawbacks of Rutherford's model. Yes or no? So then another scientist came, Niels Bohr. So what did he say? He said like, okay, the electrons are in their own respective orbitals. They don't liberate any energy unless and until they are present in their own discrete orbitals. Correct? So far, the only idea is like the positive charge is there, negative charge is there. So positive charge, when we are talking about, like this is an atom, and in the middle, let's have a positive charge. So they said like this to be a positive charge, we'll put proton P, and here somewhere then electrons can be stuck. So we'll keep this to be electron. Gradually, after a lot of researches, this particular scientist, J. Chadwick, so he came to a conclusion that something else is also present inside the atom, which gives mass for that particular atom, which gives actually the mass, okay, the measuring unit, okay, the mass. So, and that one, he named it to be neutrons. And these neutrons are actually neutral, which means like they don't have positive charge, they don't have negative charge. They are just there, which adds on or gives mass to particular atom. So when we are talking about the mass of an atom, we'll basically look into this, or the sum of the protons as well as the neutrons, right? So when we are adding this protons plus this neutrons, then only you will get this mass number. Mass number, or to say like mass number of an atom, we can say like that also. Correct? Yes or no? Correct. So this neutrons, here you just have to have only 2 points in mind. I'll repeat. Neutrons, they are neutral in charge. They give mass to an atom. That's all. Very simple. Okay. So based on the number of neutrons, for example, certain neutrons, you would have studied about this, right? I'll just tell you. See, certain neutrons, or we'll say like, for example, carbon 12. That will be easy. So carbon 12 is something where in a particular atom, okay, so here inside the nucleus, there are 6 protons. All right. And in the electrons, obviously, this is also going to be 6 electrons. Okay. And this neutron, whichever is present along with the proton here, it can be 6 neutron, it can be 7 neutron, it can be more also. Okay. So when we are adding this proton and neutron, where we are getting the mass number, where we add just this neutron and proton, we'll get 12 for the carbon. Sometimes it can be 13, sometimes it can be 14. We don't know. Okay. So that difference is what you call to be an isotope. So isotopes. So don't worry about isotopes. We'll be learning about isotopes in our next session. Okay. So next session is all about the atomic number, mass number, right? And then along with that, you will study about the isotopes. Clear? So neutrons, basically, they are neutral in charge. Okay. And they give the mass to the particular atom. Correct? Clear? Done? Shall we proceed to the next? So yes. So when we are normally looking at an atom, so this is a basic structure now. Okay. So proton, it is always positive charge, and electron, remember always it is negative charge, and neutron, it's a neutral charge. Is that clear? And proton and neutron are something which is present inside the nucleus, which gives the core, the mass of the particular atom. And the electrons, they also give mass to an atom, but it is like they are so negligible, which means like they are very, very small. That is why when 2 atoms combine together, they can share. The atom can donate, the other atom can receive. They can share one single electron into 2. Correct. So all these particular things are possible because the electrons are easy to move and they are very, very negligible in mass. Clear? Next. So yeah, make a note of this. Mass of an atom is therefore given by the sum of masses of protons and neutrons present in the nucleus. Okay? Clear? Good. So now this is something which is really important. How are electrons distributed in a different orbits or different shells, we can say? All right. So now what is there in our mind? Nucleus is there in an atom. And inside the nucleus, we've got protons and neutrons. Electrons are revolving around the nucleus. So this is a framework. Okay. So now we are going to build it on this framework. So that is why this question is, how are electrons distributed in different orbits? How are they distributed? Randomly? No. Some measures are there, or we can say like some pattern is there actually. So that particular pattern is called as an electronic configuration. We'll study about that electronic configuration. It is very simple. It is just the study about the arrangement of electrons in an atom. Okay. So for example, you take this hydrogen. Okay. For hydrogen, the mass number, we can say like it is very, very 1 only, because inside the nucleus, there is only proton. It doesn't have neutron. Another isotopes of hydrogen will have neutron, but hardly, very, very hardly it has. And it will have an electron here. Okay. So let's talk about the helium. So helium, mass number is 4, which means like it will have 2 protons and 2 neutrons. Okay. And along with this 2 neutrons and 2 protons, it will also have 2 electrons. Can you see this? 2 electrons it has. Clear? And here in helium, there are 2 electrons. So they are safely present in the first orbital because it is having only 1 orbital. And let's talk about oxygen. Or let's talk about carbon. That will be very easy. So carbon, when we are drawing it, we just have to be very, very clear. You know very well it is 6. Right? So this is a nucleus where the neutrons and protons are present. And let me draw this. So all the 6 carbon electrons, are they present in the same shell? Can somebody answer me this question? Is every carbon electron present in the same shell? No, they are not present. Are they just scattered? No, they are not. So there is a one particular pattern by which the electrons are arranged. So that particular pattern is actually called as an electronic configuration. Okay. So for that particular electronic configuration, we've got certain set of rules. I'll just tell you like what is the rule here. So the first rule, maximum number of electrons present in the shell are given by the formula 2n squared. I just wanted you to make a note of this. It's very simple. You just have to write 2n squared. So in this n is nothing but the orbit that is around the nucleus. Sometimes it can have 3 orbits, it can have 4, it can even have more. Clear? So here the n denotes the orbits, which means like if this is an atom, this is n1. So this will be n2. Like that. So this is actually the nucleus which is actually present. Let me write nucleus here. Okay. And this will be the n equal to 1 and this will be n equal to 2. Very simple. 1, 2, 3, you can keep on categorize and go. It is very, very simple. Okay. But this alone you shouldn't forget. 2n square. I'll tell you like how to use this 2n square. For example, let me just start with this. Okay. So here you've got a atom. Let me draw something which is really easy, clear. I'll draw it here. Okay. This is a nucleus. See now, in this electronic configuration or whatever, we are not going to concentrate anything about this proton or neutron. Only when we are discussing about the atomic number, mass number, we'll be discussing about the proton and neutron. Okay, so now I'll just say nucleus. Just have in mind that nucleus will contain neutron and proton. See, fine. This is a first shell. Oh my god, this is so bad. Yeah, so this is a nucleus and this is going to be my first shell. Okay. And this is going to be my second orbit. Alright. And this will be my third orbit. Let's assume. There are a lot many orbits. It can keep on going, but still. So here, this is called as a K shell. They're just naming it, okay? So this is M. And this is N. So likewise, again, it goes on. So this K, we can also write it to be N equal to 1. And this can be written as N equals 2. And this can be written as n equals 3. Is that clear? Fine. You can also say that to be shells, K shell, M shell, N shell, or according to the number, you can say like number 1, 2, 3 or whatever. There are subshells also, SPDF. SPDF we'll learn in the later sessions, but here just have this in mind, okay? So now we just have to look like how to apply this 2n square to this K. So the K shell will be very simple. I'll just write this 2n square here. Okay. 1 second. Oh. Okay. So 2n square. So this we can write it to be 2 into 1. square. So obviously it's going to be 2. Yes or no? Correct. So the next shell, L shell. So what are you going to write it there? So L is n equals 2, right? So 2 square. 2 2s are 4, 4 2s are 8. Clear? And then you will have this M shell. Wait a second. Okay. So here M you will have the third. So 2 into 3 square. Correct? 3 3s are 9. 9 2s are 18. So at last, I'm just telling you, okay? So here you have 2 into 4 square. 4 4s are 16, 32. Correct? So K, L, M, N. So this is the order. So it will be keep on going again. So just in this particular session, just have this in mind, K, L, M, N. So where K is the first shell, L is the second shell, M is the third, and N is the fourth. Fine? Clear? So next. Maximum number of electrons that can be accommodated in the outermost orbit is 8. So this is actually called as an octet rule, right? Octet, very simple. So what is octa? Octa in Greek and Latin, they say to be 8. Correct? So that is why it is also called as an octopus. Fine? So octet is one particular rule where in the outermost orbital of an electron, compulsorily it should be 8 electrons which is actually revolving. Let's start from the first shell where it will have only 2 electrons there. Okay, for example, you take this hydrogen and helium, they have very limited electrons or very limited mass number. So 1, 2, 4, just like that. So for that case, what will happen is like this is a nucleus and here you have 2 electrons, 1, 2, that's all. If it is lithium, it cannot accommodate in the first shell. It should take the second shell, second L shell there. Is that clear? Because lithium is 3, right? So the next point. Electrons are not accommodated in a given shell unless the inner shells are filled. Fine. That is, the shells are filled in a stepwise manner. For example, let's take it like this. So let's take this. Okay, so this is a nucleus. And here you have the first orbital. And then you have the second orbital. So first orbital, it has to be 2, compulsory. And the third orbital, and then where again it will start 1, 2, 3. You cannot come and fix it here. And instead of filling it here directly, you cannot go and fill it here. So these are certain rules. Fine. So next. Okay. So now we'll just, so this is a certain set of rules how to draw an element and all those things. Don't worry, after this valency we'll deal about that so that it will be easy for you. So what is valency? Can we simply say like it is a combining capacity of the electrons? We can say. So it is an ability of an atom to gain or lose an electron in order to achieve the noble gas configuration. So here you just have to look at this particular word. What is this noble gas configuration? What are noble gases? Very simple. Helium, neon, argon, krypton, xenon. So all these are the noble gases. Why are they noble gases? Because they complete or they fulfill their octet rule. So what is the octet rule? In the outermost shell, they should have 8 electrons. So that is the octet rule. One exception is helium, because helium maximum it has only 2 electrons and it satisfies the first rule, like where in the first orbital 2 electrons should only stay. So that is why helium is also a noble gas. Okay. So now, so what is exactly electronic configuration? Arrangement of electrons in an orbital is very, very simple, right? So let's start with this neon. See here, this N is a symbol for neon and this is a number, correct? So according to this, how are we going to draw a neon atom? Let's see. So this is a nucleus that you know, and here you have this first shell, and then you have, see, for drawing all these shells, please use pro circles, okay? So if you just draw it, or you can also use a compass to draw. If not, you will not get a good circle. Okay. So here you just have to draw this, and then let me just draw and complete, okay? So here, let's start with this neon. So the first shell, it should have 2 electrons, correct? So in the second shell, obviously it is going to have the remaining 8. So 1, 2, 4, 5, 6, 7, and 8. Okay. So according to the rule, neon satisfies the octet rule. Yes or no? So where in which the outermost shell, it is having 8 electrons. So when we are talking about shell, this is a K shell and this is a L shell. It's not M. Okay. K, L, M, N. Okay. It is not M again. I'll tell you. This is K. And then this is L. And then if you draw something around, then it will become an M and then it will become an N. Clear? So for magnesium, very simple. See here, let me draw this itself into a magnesium, because there it is only that much, right? See, listen. Okay, you have this, and here you will have 2 electrons. Correct? Yes or no? So this magnesium is not satisfying the octet rule. So what will it do? The magnesium cannot stay as a single element. It is a diatomic molecule, which means we don't write magnesium just like Mg, we write it every time as Mg2, like O2. Why it is Mg2? Because it will actually lose these 2 electrons very easily, to which it is actually getting combined. Yes or no? So it has a valency of 2, which means like it will give the 2 electrons very, very easily. So here we can also write it to be Mg2 plus. Okay, so why it is 2 plus? 2 electrons it is giving. Since it is giving 2 of its negative charge, 2 extra positive charges it is having. Yes or no? Since it is having 2 extra positive charges, we can write this to be Mg2 plus. Clear? Good. So next, sulfur. I just wanted you to draw this here. Yes. So sulfur, again it is 16. We can draw it very easily. You have to draw again 1, 2, and then you have 3. K, L, M. Okay, so in the center, of course, it's a nucleus, and you have the 1, 2, 3, 4, 5, 6, 7, and 8. Correct? And then here what you have? You have the remaining 6. 2, 3, 4, 5, 6. Got it? So that is why sulfur is having different dimensions. It can also exist as diatomic, polyatomic. It's actually a polyatomic molecule because it's having a lot of, the valencies is more. Clear? Fine. So in order to satisfy the octet rule, what does the sulfur do? Instead of losing 16 of its electrons, it will gain 2 of its electrons from the nearby molecule very easily, or nearby atom very, very easily. If it is gaining 2 electrons here, it will satisfy the octet rule, because in the outermost shell, of course, we have to have 8 electrons. So don't forget this. That is why I'm keep on repeating. Okay? So now, just look at this element. So this is chlorine, right? So chlorine, when we see, you have 2, and then you have 8 here, and then you have 7 here. So one area is actually free. So in this one area is only, it will actually gain an electron. So it will just decide whether to lose all the 7 electrons or to gain 1 electron. So gaining 1 electron is really easy for an chlorine. So that is why it will gain an electron here. Correct? So talking about argon here. So 1, 2, here also it has 8, and 1, 2, 3, 4, 5, 6, 7, 8. So this is satisfying the entire octet rule, and that is why it is coming under noble gas. Clear? Last, oxygen. Very simple. 1, 2. And 1, 2, 3, 4, 5, 6. It has only 6. So altogether it is 8. Correct? So it requires actually 2 of its electrons to attain its octet state, because in this last shell it is having only 6. It needs 2. Is that clear? So that is why, that is how normally the electrons will combine. I guess you know how it combines, right? Can you just recall the example that we were looking at, the NaCl sodium chloride example? Good. So yes, guys, we've come to the end of this session. Okay. So for any doubts, suggestions, just type to us, come to our web application, and they just type, or you can get the PDF notes. You can get the lecture notes, assessment questions with which you can practice in your for your exams, because your exams will also be approaching in another couple of months, right? So yes, so come visit our application and share these details to your friends, family members without fail. Correct? So if you like this, please like it, share it and subscribe it. Correct? So until and unless I meet you in my next session, this is Lavanya Elangovan signing off from Vista.